Hi everyone, I'm Ian. I do developer relations and partnerships at Tools for Humanity, the initial contributor to the Worldcoin project, and I'm here to tell you about World ID, how to use it in your hackathon project, and anything else you need to know about it. So, what I'll go over in this workshop: what is World ID, why Worldcoin created it, what you should do with it, and most importantly for the hackathon, how to integrate World ID. So, to start, World ID is our Proof of Personhood protocol. With World ID, a user can prove online that they're a unique human, doing an action only once, without revealing to anybody which unique human they are. And this is something that's really valuable online. I'm sure we've all had to do CAPTCHAs, and you've probably realized that they're getting trickier and trickier over time, and that's because AI is getting better and better at doing them. But eventually we reach a point where AI can solve any of the CAPTCHAs that we can come up with that a normal human could also solve. And if that's the case, we've got a problem, but World ID helps with that. Right? This is the big question that World ID is trying to answer. How do you know who or what is a real and unique person? We want to know that you're human, that you're not a bot. Social media's gotten ruined by bots, as I'm sure we all know. And we want to know that you're only doing something one time. Sybil resistance is something that gets talked about a lot in this space, and World ID can help with that as well. World ID has been built to be private, inclusive, and robust. Sorry, I'll stick here for a second. We don't want to know anything about which unique human you are, just that you are a unique human. We want it to be something that as many real humans in the world can use as possible, and we want to make sure it's robust so that each real human can only get one World ID, not have multiple. And we looked at a lot of different ways to try and fulfill those requirements. Using an email address or a phone number, getting multiple emails is about the easiest thing in the world. Doing KYC of official IDs is great for knowing that that person is a real human and they only have that one ID, but less than half of the global population has a digitally verifiable government ID. Web of trust systems work well at smaller scales, but a web of trust that starts with 100 or 1,000 initial trusted people can't scale to all of humanity super effectively, because every hop away from that initial trusted set you are is inherently the less trusted you are within that system. And so we settled on using biometrics. We looked at a lot of different biometric factors that you can use. Fingerprints, face scans, and palm scans all have the same issues in that A, there isn't actually enough entropy for distinguishing uniqueness at the scale of all of humanity, and B, they change too much over time. So if someone were to sign up with a face scan once and then 15 years later try to sign up again, their face might have changed enough. You can get plastic surgery, things like that. We also looked at DNA and pretty quickly decided not to go with that one because it's not private enough. You can't use DNA without knowing a lot about that person, right? Their gender, information about their race, what part of the globe they might be from. And so we settled on using the iris. And when it comes to iris biometrics, then how do we go through and actually collect that biometric data to process, but not have to store? We looked at phone sensors and off-the-shelf hardware, but phone sensors are hard to trust and also often aren't at a high enough level of detail for, again, distinguishing uniqueness amongst all of humanity. Off-the-shelf hardware had some of the same problems. It's also quite expensive, isn't very easily transported, and things like that. So we settled on building custom hardware, and I'm sure some of you have seen this hardware before. It is the Worldcoin orb. The orb has been in development since 2020. It's gone through lots of different revisions, but we are now starting to scale up production of the orbs to have them in more places around the world. And the orb's job is to make sure that you're a real human, not a cat, not a dog, not someone holding up a photo of a human, not a mannequin head. The orb takes a photo of each of your irises. On the device, calculates an iris code, a digital representation of the pattern of your iris, and then we check that that iris code is unique against everyone else who's ever verified at the orb, And once we know that that's unique, we verify your World ID. So we don't ever have to store those images of your irises or of your face. They actually get self-custodied on your phone, and you can choose to delete them if you'd like. All we have to store is that iris code. So World ID is privacy first, decentralized, and open source. So again, privacy first, most important thing is that we don't have those photos. We don't have to store them. They're on your phone, in your custody, in your control. World ID is built to be decentralized. So right now, Tools for Humanity is the only company that builds these orbs, but the Worldcoin Foundation has issued grants to other companies to start designing and operating orbs of their own. And it's open source. Every single part of the protocol, from smart contracts on chain to our developer tools that I'll walk you through today, all of that is open source. And additionally, the orb hardware and most of the orb software is also open source. There's lots of different use cases where World ID can be valuable, right? For voting, for example, being able to prove that you only cast one vote and that it's a real person who placed this vote, but not revealing who placed that vote is super helpful. On social media, having a different type of verified checkmark where you know for a fact that that account belongs to a real human, they only have that one account associated with that World ID, and that it's definitely not a bot, that's super valuable. I think customer incentives are also a super interesting one. Has anyone here ever tried to use a discount code twice? Right. I have plenty of times. Like, I've gotten my fair share of Netflix free trials before they got rid of that. But with World ID, they can know that this real person is only getting this discount or this free trial or this sign-up bonus once. And it prevents gaming those systems, meaning that they're more likely to offer you a bigger incentive or just keep them around instead of getting rid of free trials altogether like Netflix did. We've also built World ID to be super, super easy to integrate. You can use it on the web, you can use it on mobile devices, and you can use it on chain. And there's two main ways to integrate World ID. Sign in with World ID and incognito actions. So let's start with sign in with World ID. Sign in with World ID follows the OIDC specification, OpenID Connect. So if you've ever built anything that uses sign in with Google, sign in with Facebook, sign in with Apple, it's the same set of specifications there. And there's lots of different libraries and tools you can use to implement OIDC. Auth0 is a great one. Nextauth.js is a very simple to use one, where you can even custom implement the OpenID Connect flows into your application. But I'll walk through how you can do this with Nextauth. To use sign in with World ID in Nextauth, this block of code is all you need. This is the provider configuration in the Nextauth handler. So you're just setting the ID of this sign-in method. That well-known file is a file on our server that lists a lot of the configuration information for OpenID. You have to put in the client ID and client secret that you get from our developer portal when you create an application there. And then you're mapping the profile information. So the ID and name will both be the unique identifier for that user in your application for World ID, and then whether they are orb verified or simply just device verified. So sign in with World ID is super simple to use. And then we have the more powerful but slightly more complex incognito actions. And these are what most of you will likely use, especially if you're using World ID for anything on-chain. So incognito actions proves that that user is a unique human doing something usually once, but it can actually be whatever limit you'd want to set. It can be once, it can be twice, it can be 10 times, it can be as many times as you want. And then optionally, with a specific signal that is a piece of information tied to that zero-knowledge proof that can't be tampered with. So in a voting use case, for example, that signal might be which person they're voting for on a ballot. You know that that signal was an input when that proof was generated, and then when your application goes to verify that proof, if that signal doesn't match what was provided when the proof was being generated, the proof won't verify. So the user can know that their vote is actually being counted for the person who they meant to vote for. And the flow for World ID is pretty simple. The user will scan a QR code from their phone. On their mobile device that holds their World ID, they will generate that zero-knowledge proof for your application. That zero-knowledge proof gets returned back to your app, and then your app will verify that proof either with our developer portal for cloud verifications or with our smart contracts on-chain. This proof response here is what you get back from IDKit, our front-end SDK. So the Merkle root is the root of the Merkle tree on-chain that is essentially the list of verified World IDs. So anytime you verify your World ID at the orb, you share the public key of your World ID, and this only gets revealed when you're at the orb, and it gets added into this Merkle tree. So that Merkle root is valid for up to a week, so that proof can be verified for some time after you actually generate it. But that gets returned as part of the proof, so you know what root the proof was generated against. The nullifier hash is the unique identifier of the user in the context of your app ID and action. So that is what we use to make sure that a user is only doing an action once. Because every time they try to perform the same action, they'll generate the same nullifier hash. But if they try to perform a different action, they get a totally different nullifier hash, and there's no way to tell that those two actions were performed by the same person based on the information from World ID. Obviously, if they were to use the same crypto wallet or the same email address, you can tell that those are the same person. But from World ID itself, there's no way to tell. The proof is a much longer hexadecimal string than what's shown here, and that is the actual zero-knowledge proof body itself. And then the verification level tells you if that user is orb verified or device verified. And that also tells which Merkle tree to actually verify that proof against. So let's see what World ID actually looks like for an end user. So I have our docs pulled up here. We have this try it out page that just shows a nice little demo for you here. And instead of using World App, I'm going to use our simulator, which you'll probably get quite familiar with when you're building a World ID application. This is how you act as a user in our staging environment. You have lots of different identities that are already pre-verified, right? You can generate more. There's 1,000 of them for you to pick from, so I hope you don't run out in 36 hours. If you do, you might have a problem. But this button here, Continue with Worldcoin, is what your user might see on your application. So we've set our action name. There's an app ID set in our docs. We're going to say we want to require the orb verification level. So when I click Continue with Worldcoin, it pops up this widget with this QR code. Normally your user would scan this. You can also scan it with your camera if you're using the simulator from your mobile phone at simulator.worldcoin.org. But for testing, what we can also do is just click on the QR code to copy the information within it. In the simulator, we click Paste Code, and we paste it in. And it's just as if I had scanned that QR code with my phone's camera. So then in the simulator, I can choose whether I want to verify with the orb or the device credential. I'll go ahead and verify with the orb credential. And now the backend for our documentation is sending a request to our developer portal to verify the proof that was generated by the simulator. And we see that that proof successfully verified. So we're all good there. But if I try to do it again, we'll see that it won't let me. We can see that this person is already verified for this action. So when you're using our developer portal backend for verifying these proofs, it handles the sybil resistance checks, and we'll make sure that that user only gets to perform the action as many times as you set in our developer portal. But if you're doing on-chain proof verification, you have to configure that yourself in your smart contract. But now that we know what IDKit looks like for our users, let's get into how you actually integrate it. So every integration starts with IDKit for incognito actions, whether you're doing cloud proof verifications or on-chain proof verifications. And it's a single React component. We do also have a vanilla.js version of the library. I'm more than happy to tell you more about that. It's also covered in our documentation. But for the sake of the workshop here, I'll go with React because generally I see a lot of React or Next.js apps at these hackathons. So for the ID kit widget, you give it the app ID and action that you configure in our developer portal. You'll set the minimum verification level you want. This defaults to the orb verification level. If you're doing on-chain proof verifications, we only support the orb credential on-chain, so you can just leave the verification level out of there entirely. And then onSuccess and handle verify are two callback functions. Handle verify is optional, onSuccess is mandatory. They just get called at different points. Handle verify gets called as soon as that zero-knowledge proof is returned from the user, and it gets called while you saw that like pending state in the little demo. onSuccess gets called after handle verify runs, or when the widget is closed if handle verify wasn't specified. So handle verify is useful for cloud verifications where you want to show the error to the user in a pretty way if the proof doesn't verify, because ID kit will show that error like you saw when I tried to verify a second time. But onSuccess is useful for on-chain verifications where you then immediately want to go to sending a transaction with that proof in the call data. And then there's one child component, and that is the button that will open ID kit. You can configure that button to look like whatever you'd like. It's totally up to you. And then we get this proof response back, as we saw earlier. But we have this proof response back, and a mistake that I've seen people make before is that they see the green check mark on ID kit and go, okay, great, this user's verified. But until you actually verify that proof with our API or in your smart contract on-chain, all you have is a claim that this user is verified, right? You have to verify that proof. And if you don't verify that proof, or don't at least make a good effort to verify that proof in your hackathon project, you will not be eligible for bounties from us. So to verify the proof for a cloud action, it's quite simple. If you're someone who's built on World ID before, this will look new to you because we've added this verify cloud proof function that handles the call to our developer portal API for you. So all you have to do in this case is pass that proof object that you got from ID kit to your application's backend. It has to be from your backend, not from the front end, as well as the signal if you used one. So you pass the proof and the signal to your backend, and then pass the proof, app ID, action, and signal if you used it into the verify cloud proof function, and then it will return a success or failure. If it fails, it will include an error code and detail explaining the error. Otherwise, it just returns success. And then you can send that response back to your front end to present that to the user. The reason you need to do this proof verification from your back end is that on the front end, everything can be manipulated by a user. So if you only gate whatever action it is you want to gate behind World ID in your front end, the user could simply spoof a successful response from the developer portal and trick your application to letting them go forward. In your back end, it's a secure context where the user has to provide that proof, and then you get to verify it. You know it's the real developer portal that's sending that response. So that's why you have to do that from your back end and not the front end. Now, for on-chain proof verification, it's slightly more complex, as most things on-chain are, unfortunately. But we do have templates for this, as well as all of the other integrations I'm showing here. So for on-chain verification, first we have our constructor. The World ID value here is the address of the World ID router contract. This information is available in our docs. And that router contract is what you call the verify proof function on. We have this router contract so that when we deploy new contracts or add new credential types in the future, you don't have to change what contract address you're interacting with. And then you can set the app ID and action ID in your constructor to save gas if there's only one action that you want your users to perform. Most use cases will do this, but you can also pass in the action ID as part of the function call data if you have a situation where you need multiple actions to be generated on the fly, for example. And this external nullifier is a combination of the app ID and action. And that's terminology that you might have seen if you're familiar with Semaphore, a zero-knowledge proof system from PSE, from the Ethereum Foundation. And that's because World ID is built on top of Semaphore. I can dive deeper into that if you're curious after the workshop. But in this case, you just need to know that you calculate the external nullifier by hashing the app ID and action ID together this specific way. I recommend just using this code that's in our template instead of trying to mess around with it too much. So then, in your smart contract, you'll have the function that gets called to actually verify the proof and do whatever it is that the user wants to do. So for this, you can take in the signal, the root, the nullifier hash, and the proof. And the first thing we do here is we check to make sure we haven't seen that nullifier hash before. That's because we have to implement the sybil resistance in our own smart contract. Once we know we haven't seen this nullifier hash before, we call verify proof on that World ID router, pass it the root, the group ID, which will currently always be 1 for on-chain applications. That group ID of 1 specifically signifies that this is orb verification. We hash the signal a specific way in order to make sure it's within the field of the curves used for the zero-knowledge proof system. Pass the nullifier hash and that external nullifier that we calculated earlier in the constructor, and the proof. And if the proof verifies, this program will simply continue. If the proof doesn't verify, it will revert. So that really simple execution flow is how we can tell if that proof is good or not. So after the proof verifies, if we're still running, we should then mark that nullifier hash as seen so that the user can't perform that action again. And then after all of that is when you'd want to go ahead and have your code to do whatever it is that you want to gate behind World ID. That can be minting some tokens, claiming an NFT, whatever you'd like. But that should be after you mark that nullifier hash as used. So that is the overview of how to build with World ID, what World ID does. You can go to worldcoin.org/Sydney24 to see a Notion page that has a lot of this information within it, links to our template repositories, and you can also find me at our booth. I usually don't sleep very much during hackathons, because if I wasn't here working, I would be here hacking with you. So I'm more than happy to help out, answer any questions you might have, and thank you all so much for your time. Yep.
When you take a question in Swedish for the audio-visual to pick it up. Thanks.
All right.
So it sounds like there's the cloud and then on-chain for incognito actions and then the sign-in. What's most popular right now? What is like World ID see as going to be the best use case, the most popular use case?
Yeah, so the question there was that we have sign-in with World ID and then incognito actions, both cloud verified and on-chain. Which one is the most popular? Which one do we want to see people using? And the answer there is that in terms of World ID integrations that are live in production today, it's split mostly between sign-in with World ID and World ID with cloud proof verification. But for hackathons, most projects will use the on-chain proof verification, right? That is the crypto native way, because most of what everyone's building here is on-chain to some degree. Most people will use that on-chain proof verification, but any of those are totally fine to use. All of them make you eligible for bounties. We don't have a strong preference about which one you use, but if you're curious which one is best for your specific use case, feel free to come ask me at our booth. Yes?
How does the on-chain verification work? I mean, not what we do, but what you do after we caught your router. Right.
So the question there is how the on-chain proof verification actually works. Like, what do our smart contracts do? And I will try to keep this one short because I could ramble about this for an hour, depending on how deep into zero-knowledge proofs we want to get. But essentially, our smart contract is first checking to make sure that that Merkle root provided is a valid Merkle root. So it's checking against the smart contract that manages that Merkle tree, that this Merkle root is one that has been generated by Worldcoin within the past week, that it's actually a real Merkle root there and not one that you just made up that adds identities that don't actually exist. And then it's doing all of the math to verify that zero-knowledge proof from the mathematical perspective. It's a Groth16 proof. As I said, it's based on the semaphore protocol, so you're essentially proving that you control the private key to one of the World ID public keys that is a leaf in that Merkle tree. So I'll leave the explanation at that for right now, just because it takes a lot longer if I want to get much deeper than that.
A very basic question on what chains does it actually work?
That is a great question and something I should have gone over in my workshop. Yes, what chains it works on. So the canonical version of that Merkle tree is on Ethereum mainnet, and those Merkle roots currently get bridged to Optimism and Polygon. On the testnet side, Ethereum Sepolia, Optimism Sepolia, and Base Sepolia are what we support. We don't support Polygon's new testnets quite yet.
Question. So for the login, if you use Google login or Facebook login, they'll exchange a long-term token, so that way you verify the server with a handshake and you got token for interactions. Does something similar happen here with the login where you have the handshake, you verify with the server for the group? Is there a long-term or short-term token that's used for server verification, or do you, like, is it just a handshake level, or do you just generate a future login?
So the question there was if we get a long-term access token back from sign-in with World ID. And there's some nuance there about the overlap and separation between OIDC, which is for authentication, and OAuth2, the standard that OIDC was built on top of, OAuth being for authorization. Right? So when you use OAuth for signing with Google or signing with Facebook, you get that access token so you can do things like post on Facebook on behalf of that user or see the photos associated with their account, depending on what the user authorizes you to do. You do get an access token back depending on which OpenID Connect flow you use for your application, but the only thing you can use that access token for is calling the user info endpoint that will return the exact same information that would be contained within the OIDC ID token, which is a JWT. So there's no actions you can take on behalf of a user with World ID, but it is simply another flow by which you can get the nullifier hash to identify that user, know which verification level they have verified with, and I can go a little bit more. I don't know exactly how long the access token is valid for. I believe it's up to a week, but your user should get signed out of your application after some period of time anyway, and then when they sign back in, you'll get a new access token and can call the user info endpoint with that new access token. Yes?
Is it possible to get back information about the user with the other interactions between the signing and World ID?
So the question was if it's possible to get back information about the user when using sign-in with World ID. And the answer is no. We don't have information on that user to share with you in the first place. We don't have their name, we don't have their email, we don't have their phone number. All you get back is the nullifier hash as the user sub, the identifier of that user. And that nullifier hash is only specific to your application. If I go sign into a different application, I get a different nullifier hash. We do include like name information that is World ID user and a fake email address that is that nullifier hash at id.worldcoin.org. Those values are there for compatibility with certain applications that expect those values because they are typically provided when you use OIDC. Right? If you sign in with Google or sign in with Facebook, the email address of your account gets returned as part of that. So some applications break if they don't have a value for that, but that email address can't accept emails. That name is always World ID user. So all you get is that unique identifier and then whether they are orb or device verified. I'll go with you back there.
So NFT mints and like token claims are pretty clear application, but do you have any examples, like some cool examples of where we can use this on chain?
Yeah, so the question was like, if we have cool examples of how we can use World ID on chain other than just like NFT mints or airdrop claims. And I think my favorite on-chain application that I have seen at a hackathon was from ETHGlobal New York last year. And there was a team that used World ID as a mechanism to recover ownership of a smart contract in case you lost the keys to the EOA that had the owner role. That was one that I thought was really, really neat. But one other thing I'll say that can unlock a lot of use cases is that in your smart contract, instead of simply storing a mapping of nullifier hashes where you mark a nullifier hash as true once you've seen it, you can do things where you can mark, or you can associate a wallet address with a nullifier hash and allow a user to mark that wallet as verified and unlock multiple different actions within your smart contract based on having verified once.
Maybe to add to that, you can actually in many cases avoid KYC, where the KYC is actually only needed to identify a single person to make sure that the same person doesn't claim, in the simplest case, airdrops, but it could be anything else.
Yes. So the question there was like, if we can use World ID to replace KYC for use cases where they just need to know it's a single real person. And there's some nuance there, right? If it's KYC where there is some like government regulation requiring that you know who the person on the other side of a transaction is, World ID isn't a replacement for that. But if it is someone doing KYC just because they want to know they can ban you really effectively in the case that you have abused their platform or something like that, World ID does act as a replacement for that, right? In the back.
Is there an alternative identification mechanism, say if you have a board without iris or you have an accident?
So the question there was if there's a way to verify other than using the orb for people who may not have irises or other situations like that. And in World ID right now, there are two credentials that we support, right? Orb verification that we see as the like gold standard. This is the highest level of proof of personhood that we can achieve. And then there's also the device verification credential. So that means that you've installed World app on your phone. We know that that phone has only had World app installed on it once. And that is a much weaker sybil resistance mechanism and a much weaker proof of personhood mechanism, but it is still better than nothing, right? Because your cost to duplicate those is going to be, you know, roughly $100 or higher for every separate phone you want to get. In terms of longer term, we're definitely looking at adding other credentials to World ID. There's not any that we've settled on right now, but when it comes to how we scale to all of humanity, when there are people who may not have eyes, for example, I'll answer that because I think that is a good adjacent point here. And I talked a little bit earlier about how web of trust systems don't work well when you start with 100 or 1,000 people in your trusted initial set. But if we use the orb as a way to bootstrap a web of trust, where if we reach 1 billion people verified at the orb, suddenly that web of trust can scale to all of humanity much more effectively. That's one of the potential routes that we're looking at. None of that's set in stone, but that is a good point you brought up.
What's the orb plus versus orb difference, and how do you use the orb plus?
So the question there is, what's the difference between the orb verification level and the orb plus verification level? I can tell you've looked at our documentation. So the orb plus verification level isn't live yet, but the orb plus verification level will actually be verifying that the person who clicked verify with World ID in World app to generate that zero knowledge proof is the same person who verified at the orb. So I talked a little bit about how the images taken by the orb are self-custodied on your phone. And what that orb plus verification level will do is actually have you take an image of your face on your phone. It will compare it to the image that was signed by the orb and then stored on your mobile device. And then it will sign an attestation that includes both the app integrity, so that we know it's actually World App that generated that attestation, as well as claiming that, yes, it did verify that the person who took a photo right now in front of the phone is the same person who verified at the orb. Any other questions?
So that would be just a face image, not an iris scan, of course, because phones can't yet scan the iris.
Right. It is just a face scan. The iris is primarily for deduplication, right? Only letting you verify at the orb once. But for making sure that it's the same person using that World ID to discourage people from trying to share their World IDs, for example, the face image works well for that and is something that is achievable by current phone hardware. You back there.
Any thoughts on open sourcing the orb?
It is. It's 90, like the vast majority of the hardware is open source. There's two things that aren't open source in the orb hardware. One of them is a camera board that is licensed intellectual property so that we don't have the rights to open source that. And the other is the security board that handles the encryption, signing, and tamper resistance of the orb, which isn't open source for fairly obvious reasons. And then on the software side, it was fairly recently that we open sourced most of the orb software. Again, there are some parts of that that are licensed or security sensitive that aren't open source yet. We want to open source them eventually though, so that will gradually be even more and more open source, but you can look at the majority of it today.
It's mainly just wondering how much of the verification is done through like security via security. How much of that security is based on only user attack?
That's a great question, and I would love to put you in touch with some of the engineers working on that to answer that, because I don't want to answer that potentially incorrectly. All right? All right. Thank you all very much. If you have any more questions, feel free to come find me at our booth.